The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone and thank you for attending today's webcast, AnyCAD, your key to Revit and Inventor collaboration. Our presenters today are Clayton Petmiller. He is an MCAD solutions engineer with Hagerman and Company, and also Daniel Rosenberg. He is an AEC solutions engineer with Hagerman and Company. Before we begin, I'll let you know that you are in listening only mode. If you think of questions during the presentation, you can type those into the question panel, which is located on the right-hand side of your screen, and they will be addressed at the end during a Q&A time. As we close down the session today, you'll be prompted to fill out a short survey, and we do ask that you take a few moments to fill that out for us. It is helpful. Also, all registrants will receive a follow-up email tomorrow containing a link for the recording of today's presentation. Now I'm going to first hand things over to Clayton.
Thank you, Ashley. This is Clayton. Hopefully today we'll answer some questions about the Inventor and Revit workflows, or Revit Inventor workflows, whichever way you want to phrase that. You can use Inventor files over in Revit, and you can use Revit files in Inventor. So we do have sort of a bidirectional possible workflow here. We've gotten a lot of requests from the world about, you know, I'm a part designer. I build, you know, maybe it's window casings, maybe it's an escalator, maybe it's an elevator. There's a lot of mechanical builders out there that build parts and pieces that belong inside buildings. Well, on the mechanical side, we use Inventor to design things. Over on the Revit side, they use Revit to build buildings. So how do you make sure that what you're building in Inventor is going to fit inside the Revit building and vice versa? Well, that's kind of what today's topic is about. I know the intro that we put out there on the web said AnyCAD, and we'll show you how that fits into this. But today's discussion is basically AnyCAD, working from Inventor files over to Revit and vice versa. Again, my name is Clayton. We've also got Dan assisting over on the Revit side. Unfortunately, I don't know Revit, so I have to lean on Dan here a little bit. And Dan doesn't know Inventor, so he has to lean on me a little bit. So anyway, we shall proceed. Our objectives today, I kind of broke this just into two simple parts. If I'm working in Inventor, how do I get my stuff over to Revit? And part two, if somebody's working in Revit, how do they get that over to Inventor? So we are going to show both workflows, just simply part one and part two. For part one, which is the reason I started off this presentation today, I'm the Inventor guy, so I'm going to basically prepare my work to go over to Revit. Usually that's done through an Inventor to Revit export or creating an RFA file or Revit family. We'll talk about the actual steps you have to go through to do this. I'm going to first show the steps through a PowerPoint so you can kind of have screen images of everything. Then I'm actually going to launch an Inventor part and do it manually in a demo. So this is our process as far as beginning this webinar. To go from Inventor over to Revit, the recommended steps that you should be doing, not everybody does every one of these steps, but this is what's recommended. First and foremost, you should simplify your model. My model today happens to be a water heater. Now, as far as simplifying the model, I can break that water heater down and reduce a lot of the internal components. Anybody that's looking at a water heater, you don't see the tank that's in there. You don't see the batten insulation that's in there. You don't see a lot of the stuff that's inside that container. And honestly, any architect putting it in that building, he doesn't need to see that kind of stuff. So simplification kind of makes sense, and we'll talk about different reasons why you would simplify. You're going to add your mechanical connectors, your MEP connectors. You're basically sending the information over to the Revit person as to where things are supposed to connect to your model. You're going to go through an authoring process, which is basically putting additional metadata in with your component. And then ultimately, you're going to publish it or save it. So I've shown a few toolbars here that you're going to be looking at today. We'll discuss these one at a time. First thing I want to talk about is simplifying the model. The tool to use for this is Shrinkwrap Substitute. The Shrinkwrap tools are going to help you remove unnecessary components and features. They're going to combine everything into one simplified part. So you don't need to send like a water heater assembly to the Revit guy. You just need a part that represents that water heater. You can send them the assembly if you want, but normally people go through a simplification process. The Shrinkwrap process. First thing, if I take a big assembly in Inventor and I reduce it into a single part, I'm also reducing the file size. So rather than sending them some massive email or some cloud share to get this massive file to them, I can just shrink it down to one simple part and actually probably drop it in an email to them. It obviously, because of the shrinking and reducing the size, you're increasing the performance as well. Another reason people use shrink wrapping. There's a lot of components that you might have in your device that might be proprietary or intellectual property. By shrink wrapping, I can actually remove a lot of that key information that you want to protect for yourself, but still allow them to have the full water heater for size and positioning within a building. So simplifying it is basically what people do as they build these models and attach their BIM content to it. You'll see this more as I actually do the demo. As far as the shrink wrap command, I've got some slides here just to kind of walk you through the process. First of all, since we're in Inventor, we have different design views, different positional reps, different levels of detail. Design views are sort of a visual. What do I want to show when I send this out? Do I need to show all the pieces or should I hide some of them? You know, maybe you want to hide the rivets and stuff that are holding the sheet metal casing onto the water heater. Positional representation. Now, water heater doesn't have different positions, but if you're doing like an elevator shaft, an escalator, or any other kind of device, you may have multiple positions that your device is capable of. You can choose which position you want to send out. Again, level of detail kind of goes through the I can't even say it, simplification process. Anyway, the next thing on this dialog box, remove parts by size. A lot of people do sheet metal components nowadays. You might have rivets, screws holding that sheet metal together, bolts and nuts. There is a section in this dialog box where I can remove parts by size. So if I've got a row of rivets around the top of this water heater holding the top to the cylinder and the bottom would be held to the cylinder, I can basically say, you know what, those parts are so small, it really doesn't matter, just remove them. So remove part by size, I just put in a number and it takes away all the little stuff. You can also remove parts by selection. Maybe there's optional parts that go along with your device and this particular customer doesn't buy those optional parts. So I could select those optional parts and say, you know what, they don't need that right now, I'll just take it off my assembly. I'm not going to build them a new assembly, I'm just going to use the one I've got and just take off the parts that they didn't purchase. So that's also something nice to know, is you can remove parts by selection. You can remove holes. Now, there's 4 different categories here. Removing holes. I just sent a tubular frame out to somebody the other day that had all kinds of holes drilled in it. They didn't need to see all those holes. Well, basically, the more geometry you have on the screen, the bigger the file is and the more load it puts on your video card. So sometimes you're just going to be like, okay, your choices are, you can say, no, I want to see all the holes, or no, I want to take all the holes away, or you can actually just say, you know what, take all the holes away that are less than 1/4 inch in diameter. So example, on the last page, if you took all the rivets off, on this page, you probably just want to hide the small holes that those rivets were going into. So I would probably remove holes by using a certain diameter. You can do the same thing with pockets. Sometimes it may not just be a round drilled hole, maybe it's a slot or some irregular shaped pocket. You can do the same thing. hide all the pockets, don't hide the pockets, or remove pockets by size. Now, with a hole, they use the diameter. With a pocket, because of irregular shapes, they use basically the perimeter of that face loop. So removing holes, removing pockets is an option. You can also remove fillets. Same thing. If you've got little bitty corner radiuses and all that really don't matter on the shape of the object, you can remove fillets, all or nothing, or by a maximum radius. Maybe you just want to get rid of the small fillets. Same thing with chamfers. Chamfers and fillets kind of go along together. That's why they're on this slide together. Again, all, nothing, or by size. There is a preserve features down at the bottom. If I come in here and I make some grand decision that I just want to hide all the holes in my object, just turn all the holes off. Well, some of those holes, like a water heater, may be where the gas line connects or the water line connects or the exhaust connects. I can tell it to hold, basically hide all the holes, but I can specifically say, you know what, preserve this, keep this one, keep this one, and keep this one, because those are connections. I need the customer to see where those holes are. So as you're going through this whole hiding process, you can still manually override and say, you know what, I want to preserve these certain features. So it ignores any holes, pockets, fillet, and chamfer rules that you've written up above. So that's kind of the shrink wrap process. Ultimately, you're going to create it. The creation process is pretty simple. You're going to give it a name. It can be any name you want to put on it. It can be a company part number, whatever. Tell it what template you're going to use. Since the shrink wrap is actually changing an assembly into a component, it's going to be a part template, so I could use a regular part template. You're obviously going to give it a file location. Sometimes I just put it on my desktop so I can drop it in an email and send it, or sometimes I'll put it with the actual assembly model. I can also set BOM structure. Down at the bottom with the style, there's 4 basic styles. One, when you send your party out, you can send it as a single body that has no seams on it whatsoever. So if you've got 2 parts butted up against each other, it would look like one part. Single body with seams, if you have 2 parts that are butted up against each other and you want to see that line between the 2 faces, you can show it with the lines. It's still going to be a single solid body, but you can show a seam there where where the 2 parts actually meet each other. You can maintain each part in your assembly as a solid body. I wouldn't recommend that one because it creates a lot bigger file. But sometimes if the customer is going to be removing particular parts out of your assembly, or they want to actually manage the solid bodies by hiding or moving some of the solid bodies, you may send it that way. Again, most people, the goal is to lightweight it as possible. So you can do it as individual solid bodies. I wouldn't recommend it just because of file size, but you can. And single composite, I haven't seen anybody use that one. It basically is the same thing as a single body, but it creates it as a surface model. So there's no internal structure. It's just like a shell of your model. The reason I don't see people using that, people don't use surfaces that much, but it is an option and it is super lightweight. It's actually more lightweight than a single body solid is. So that would be the only benefit to using that, is just to have it as lightweight as possible. So those are your style selections. I believe we got one more slide. Down at the bottom, you can have your shrink wrap part actually linked to your assembly. A lot of people work in that fashion because if they update or change the size of their assembly, they want that shrink wrap part to also reflect that size change. So as long as you have a link between the two, any assembly changes are going to instantly be recognized in the shrink wrap part. Now, if my goal is to send it to Dan and I know I'm never going to see it again, I'd probably break that link just so I don't have any cross-part associativity trying to happen on my computer. You could rename components. If you turn on rename components, it's going to pop up another dialog box that basically says, what parts in your assembly do you want to rename? This is really only going to be relevant if you're doing the individual solids option. But basically, it gives you a chance to hide your company part numbers and just put in bogus names. So you're not exposing proprietary company information to your customers or to your vendors, whoever they're sending this to. You've also got color overrides if needed. The two switches I use all the time are the two on the right. Fill internal voids. I believe I might have another slide for that. Yeah, fill all internal voids. Basically, like I said with the water heater, do they really need to see the insulation wrapped around that inside tank? None of that is actually visible to the end user standing on the street looking at this water heater. If you go to Home Depot and look at one, you don't see the tank inside of it. So do I really need to expose that to anybody? If I just say fill all internal voids, anything that's trapped inside a cavity is just going to be filled with solid. So it hides all that proprietary information, and it also reduces the size of the model because you're eliminating a lot of parts. I sent a transmission to somebody not too long ago, and I took all the gears and guts out of the inside of it. They just wanted to see if it would fit inside the car. They didn't need to see the 200 gears that were inside that transmission. So again, it's all about reducing the size of the model and just eliminating things that are totally unnecessary to the person you're sending it to. And lastly, there's a preview button at the bottom. You should always preview what you're creating so you know what they're going to see when they get it on their end. And you'll see this as I do the demo. But that is the shrink wrap process. After you shrink wrap it, you're going to add your connectors. Now, the software has built-in connectors for cable trays, conduit connections, duct connections, pipe connections, and electrical connections. We'll look at all these individually. Example for cable tray. It could be a rectangular shape or undefined. You're going to see undefined a lot because not all cable trees are rectangular. Undefined is kind of a catch-all that catches all other shapes. Now, connection type in this particular example, you've got electrically bonded or undefined. Again, sometimes those cable trays are ground strapped. That would be bonded. If it's not, again, undefined is always your opt-out for any other condition that might exist. So that's a cable tray connector. Conduit connector, usually circular. All the conduit I've ever seen has been round, but they also have undefined. With conduit, you have different connection types. They're compression, they're glued. The ones I get at Home Depot are set screw connected. Some are threaded, and again, if you have something unique that's different from the other four, undefined. For duct connectors, there's all kinds of duct work out in the world. Rectangular, circular, oval, again, undefined. There's system types, so as you're putting in this ductwork, you can tell it what it's for. Is it for exhaust? Is it for a return? Is it a supply line? Is it other or undefined? You all have these choices. Piping connectors. Again, most pipe is round, circular, but again, if you have something different, it could be undefined. System types. You're going to tell it what kind of system type it is. Now, in my water heater, I'm going to use this one. It's actually a domestic water, hot and cold connection. There's fire protection connections, wet, dry, pre-action, or other. Hydronic supply and returns, sanitary connections like drains. Again, they also have other and undefined. Electrical connections. Wow, when it comes to electricity, it's not just about electricity. You've got communication cables, control cables, data cables, fire alarms, nurse calls, power lines, balanced or unbalanced power, security lines, telephone lines, and there's probably a dozen more that I didn't even get on this list. I was running out of room. And you can also put in any user-defined properties to tell it what this connection is. So, you know, it could be a data connection, but, you know, maybe you want to specify whether it's a 5-volt or 12-volt. Again, all the information you need to put into your model, it's easily done through these interfaces. Once you've done with all your 5 types of component connections, the next thing you're going to do is author the building components. Now, the authoring process has to do with model orientation. And I'll show you this when we get into the demo. My water heater, when it got built, is actually laying on its side. I don't want to send it to Dan with it laying on its side. It's supposed to be standing up. Well, I can basically set up the coordinate system and set up where the insertion point is. I'm probably going to use the bottom point of the water heater where it sits on the floor. You also put in all your metadata. Does it belong to a particular Omni class number name? You can put in component properties like what's the description, who's the manufacturer, what's the model number, what's the model properties, who's the vendor, what's the cost. I mean, any kind of property you can imagine, you can pretty much tag into this water heater and let it build in knowledge. So the more time you spend here, the more knowledge you're actually putting into the model that you're sending out into the Revit world. And the last step is the actual export. When you click that export building components, you're doing a save as. It could be saved as a Revit family, an industry foundation class IFC 2x3. I don't know what that is. Dan may understand that language. I don't necessarily. Or the typical Autodesk Exchange file, ADSK format. In my example today, I know Revit likes the family format, so I'm going to send it out as an RFA. So I've done enough talking about what you need to do to send a model out to Revit. Let me go ahead and proceed and show you the steps. Okay, so here's Inventor. First thing I'm going to do is open up my model. And you can see it's a basic water heater. Got some feet on the bottom of it. Pretty simple looking. But as I was going through, I'm going to go through the same steps here. Where you're going to find these tools is under the Environments ribbon. When I go to Environments, you'll see a button there that says BIM Content. BIM Content. When I click on that, here's the ribbon I had in my PowerPoint. The very first thing I want to do is the first thing that's on the ribbon. Shrinkwrap Substitute. Here's the dialog I was showing you. I'm going to use the Master Design View, Master Rep, Master Level of Detail. I don't have any parts to remove by size because this fillet has a fillet on the top instead of a sheet metal riveted together. I don't have any particular parts I need to hide or exclude, so I really don't have to do anything on this front page. Features. Now again, removing holes. Well, I really don't have any holes I want to get rid of. The ones that are on here are the ones I basically want to keep. So I don't have any holes or pockets to remove. Fillets, just to show you some of this. If I say remove all detected fillets, look at this up here. When I click preview, you can see that it removed that fillet. And it probably removed a few fillets off this container down here. I wasn't looking very close before I did that. Anyway, if I want to show all of them, I can hit preview. There's all of them. Again, chamfers, I don't have any chamfers, but again, this is where you do a lot of that component hiding. Mine's a simple component, so I don't have a whole lot to hide. When I go to the Create tab, water heater, I'm going to give it a name, water heater simplified. We'll take that little underscore out of there. I'm going to use the standard part template. I'm going to put it in my webinar folder under water heater. Normal bill of material. I'm going to do the single solid body with seams in between. I'm going to go ahead and break the link because I don't need to keep it connected. I don't need to rename anything because I'm not concerned about that. I'm going to use the color overrides and I'm going to fill all the internal voids. So when Dan gets this, it's just going to be a solid mass. Again, I click preview. Preview looks good. I'm going to say OK. And it comes up. And I forgot to do something. I forgot to make my connection. So I guess I'll do it again. No, I don't have to do anything. I'll just come in here. We do have a duct connector on here. When I do a duct connector, My duct happens to be circular. I could type in a diameter, but it's easier just come to the model and pick a circle. So it sees that as a 5-inch diameter. System type, this would be an exhaust. No loss method. Connection type, it's going to be a flange. Flow direction, it's actually flowing out. And description. Natural gas exhaust. So that's how you put in a connector. Just hit apply and done. So there's a duct connector. I'm also going to have pipes connected to this. So if I come in here to pipe, I just need to select like this fitting right over here. There's a pipe. Now, this is a little bit deceptive. This is something I learned the hard way. These arrows are supposed to point away from the connection. That basically connects to what Dan's going to do on his end. That points away. When you come in here to system type, like this is my domestic cold water inlet, I can come down here and I can say that the flow direction is in. So even though that arrow points up, it's actually a flow going into the tank. And it's not a braze connection. A lot of connections in here. This one happens to be threaded. And then for description, cold water supply. Okay, so I can come over here to this one. Let me repick that. I want the arrow to point up. It is circular. This is going to be domestic hot water. And moving up, flow direction is going to be out. It is not a braze fitting, it is a threaded fitting. And under description, hot water outlet. Okay. Now over here, we've got another threaded connection. We'll grab that, kick the arrow out. Now, this is not domestic hot or cold water. It has nothing to do with protection, fire protection, hydronic. I can just say other. Come down here. The flow on this is going to be outward. It is also a threaded connection. Then I can come down here. Just label it as pressure relief valve. And we got one more connection down here. Grab that. System type. Again, I can label it as other. Flow direction happens to be internal. Got a lot of threaded connections on this. Everything on this is threaded, but you can see you've got a lot of choices. Description. By putting natural gas supply in there, they know it's not for an LP or other type of gas system. So when you do all that, you get your ductwork connector and all your other piping connectors. These are all important information that Dan's going to be able to use. I did not go through the author process. Basically, the authoring is where you set up that orientation. I do not want my water heater to be based on the model origin. I actually want to use the actual view cube where I've got the top labeled. So it's going to be standing up. Omni class, if I click on that and just type in the word like water. Oh, there we go, water heater. I don't know a lot of this Omni class numbering and all that. I'm not an architect, but when I go to water heater, I can find what this actually is. It's not thermodynamic, it's not instantaneous, it's a storage water heater. Boom, done. So even though I don't know all the codes, the software helps me with that. And down here where you can add more information, I put in the water heater, Hagerman and Company, model number HAG45. You can even put a web link in here. Again, the more information, the better. So we put all that information in, and eventually you would say export, go to my water heater file, and save it as a water heater RFA. Save, yes, go ahead and replace it. So it's going to build a nice little Revit family out of this water heater with all the connections on it. And then I'm going to send it to Dan and let him take over. Dan, are you ready?
Absolutely. Great stuff, Clayton. Thank you for that cool demo. I'm ready to roll here. So let's go ahead and get my screen share going. Just let me know if that doesn't come up for you guys. Looks good. Okay, great. So today I'm going to be playing the role of the MEP engineer for starters, and I'm going to take that water heater that Clayton sent over to us and insert it into my building model. So I'll open up my Revit project file. And here we go. So let's say I'm going to zoom into my mechanical room here. We're ready for our water heater. We'll go to, we could do it two ways, but I'll just go to Insert, Load Family, browse to wherever I've saved it. This is what Clayton sent over. Go ahead and click Open. You got a nice little thumbnail preview there. You can see the geometry and the connectors. So I've loaded it in to my project. Now I need to place it. So I can go over to the Systems tab and find the Mechanical Equipment button. And of course, I've got our favorite plumbing consultant to help us out, as always, here. And you can see I've got the water heater loaded in, and I'll just kind of zoom in and get it roughly where I need it to go. As soon as I place it, let's select it. You can see the connector points located right here, but let's take a look at this in 3D real quick. So if I go into a 3D view, we can see the actual unit and check out all the connectors within the context of our building. And go back into floor plan here. Let's say I'm ready to draw some piping from the connectors. But before that, you know what, let's take a look at some of that information Clayton put into the component. If I click on it, here's all the properties of this element. We can go into the type properties here. You can see all this information that was added in. You also, and this is pretty nice, you have the ability to modify the size of the connectors if you need to. And let's go ahead and draw cut a section real quick here. And you can see that looks like the origin point was at the bottom of the tank. Easy fix, just click on it. We have a little parameter here. Bump it up to floor level. Now, there we go. If we click on it, a little button here that will allow us to draw a pipe coming straight out from the unit. Can change our detail level. If we need to, could do the same thing. Hot water supply. And we've also, let's do some duct work for our exhaust. And then if we go back to 3D, let's take another look at this real quick. Of course, we're in a coarse level of detail or medium. Let's switch it over to fine here. You can see the actual geometry, and that's what it looks like on the Revit side. So this is ready to use. We can connect it to our plumbing fixtures if needed, and fully functional Revit family. Fantastic. So the other workflow that we wanted to show today is, well, what if I've got my building model here and Clayton needs to do some work that directly references parts of my building. And one of the examples he mentioned earlier was, you know, what if we're doing some sort of window casement or overhang awning? You get the idea. So what will we do in that case? Well, the good news is we can actually send him our Revit model, and he can reference that inside Inventor. So how do we do that? Well, I've put together a quick little PowerPoint here on how that's done, especially to get it started from the Revit side. And then once we get the Revit model ready, we'll hand things back over to Clayton. So here's the PowerPoint. All right, so most of these workflows are extremely new, and Clayton and I had to do a little trial and error to get these things working properly. The plan is to show some of the hurdles we ran into and what we did to overcome them. So on our first pass, we wanted to see what would happen if we simply took my working Revit building model and tried to bring that into Inventor. And I will admit I started with an extremely light data set to begin with. It was a simple shell model with not very much on the interior. The thought was, hey, wouldn't that be nice if I could just hand off my model and let Clayton do his thing on the Inventor side? So I sent my model to Clayton, and here's what happened when he tried to load it into Inventor. As you can see on the screen, he received a warning message. Now, we could have proceeded with this, but looking at this dialog box and the warning message, we knew we could make some simple modifications and make this process a little smoother. So let's break this down a little further. The ignorable warning message shows that we have 10,388 elements shown in this view, and it's telling us it would be best if we could get that down to less than 250. Now, you might have also noticed that we have the ability to filter out certain categories from the Revit model. While this is great and might be useful, we might be better if we could isolate the exact area of work before even bringing that into Inventor. So there is one other thing I saw that caught my eye in this dialog box that is important. And you have the ability to choose a 3D view from Revit upon import. When I saw this, I knew I could come up with a viable workflow and outline these steps for you. And I admit it would be awesome if we could simply send our Revit model as is to the Inventor users. However, since we probably shouldn't do that anyway, the good news is that we can run through these simple steps in Revit. This will streamline the process when the model is brought into Inventor. And I'll give you a chance to look over these bullet points because these are the 3 main steps we'll be taking. And I'll go into each one of them in a little detail as we proceed here. Okay. Now, remember back when we looked at the import dialog box in Inventor, you saw we had the ability to choose a 3D view from Revit. Most users might think, okay, so what? All that does is control what I see after importing this giant building model. Well, not exactly. Autodesk actually did us a huge favor by allowing us to choose which view to import. By choosing the view we want, this gives us the ability to control not only what we see, but what gets imported. This means that if we have a nicely curated 3D view ready to go for Inventor, then we can control precisely what will be shown and modeled in Inventor. And in our case, what is just as important is what's not going to be shown or imported or referenced. So if we zoom in to the project browser in Revit, you can see a whole list of 3D views saved into this project file. And this is where I can duplicate an existing view and or designate one as my Inventor view. And I went ahead and did that on the screen, as you can see. So now that we have the dedicated view, we still have this giant 3D model, and that brings us to our next step, which is to isolate the area of work. And that can be done by selecting a few elements you want to include and typing the keyboard shortcut BX for the box command. And after I've done that, my view now looks something like this. I have selected the section box and it's highlighted in blue just by clicking on it. And you'll have the ability to use these press pull buttons to further isolate your geometry. And this is all inside that Inventor 3D view. It doesn't affect any of the other views in the Revit model. So the next thing that I can do is simply hide all the items I know are not needed in Inventor. For example, the site topography, I'll do a little before and after. This is the before, this is the after here. And so I could get rid of site topography, furniture, and fixtures, and it should look something like this. I also went ahead and turned off the curtain wall mullions because there were a lot of them, and I also did a crossing selection and found that there were a total of 111 items shown in this view, and well under that 250 items that prompted that alert in Inventor. I should point out that it might not always be possible to get under 250 elements, and that's perfectly fine, as you'll see again in a little bit in the presentation. So the cool thing is that now that I have this view created and all the geometry filtered out that we're going to need, if I have any design changes down the road, I can just save my file the way I have it and send it off to the Inventor users, and they'll have that view. So with that, I believe I am ready to hand it back over to you, Clayton. So I will send it back over your way now.
All right. And I believe I'm up and running.
Looks good.
All right. So I kind of started in the middle. Dan's already started this, but anyway, Revit to Inventor is obviously the conversation here. For the Inventor steps, basically you just want to create a new assembly file, or you could be using an existing assembly as far as that goes. You want to use the import CAD file, which is basically the AnyCAD command. Importing the CAD file using AnyCAD, it will link the file. We'll show you the dialog process here in a second, and assemble the rest of your components as needed. So just give you an example. When you import a CAD file, you can find this in the Inventor menu in two different places. One, under File, Open, there's an Import CAD file, and that's what the dialog looks like. Imports other CAD formats into a new Inventor file. Now this works with Revit. It also works with just about any other modeler on the market. whether it be SolidWorks, Pro Engineer, CATIA, SDRC, Gen X, whatever CAD program you're using, you can pretty much import these files. Now, again, first place to find it, File, Open, Import. The other is on the Assembly ribbon in the Component panel, where you usually do a Place or Place from Content Center. You can just do a Place Imported CAD file. Icon looks basically the same, but the wording is slightly different on it. But those are the two places you can find this command. When you launch the Place command, the first thing you're going to see is this dialog box. It's going to ask you what kind of import are we doing. If you do a convert model, you're basically converting it into a complete Inventor assembly, and it would be converted. It's a one-time pass-through. Like for Dan's building, I don't want to convert it into Inventor. I just need to see it. I'm not building his building. I'm just adding stuff to it. So instead of converting it, I'm going to read it in as a reference model. Now, the keynote here, you see the little link, chain link. If I bring it in as a reference model, it comes in as kind of like an underlay. And what that allows me to do is it's linked to the Inventor or the Revit model, which means if Dan sends me a newer, updated Revit model and I'm linked to it, Inventor's going to instantly see those changes and say, hey, the Revit model's changed. Do you want to update it now? That permanent link is everything. And Dan already talked about the view selections and the categories. He talked about that on his end. I had it on my end just in case. But I could filter out walls, doors, floors, whatever devices I don't want to see, I can filter it out. I can also select which view Dan set up for me. So again, a little repeat, showing the same thing we're showing on both ends, but straight to the demo. So let me jump over to Inventor real quick. Now on Inventor, in my case, I'm going to start a new assembly file. So I launch my assembly. And again, just like any other assembly, when I go to Place, I can do a Place, Place from Vault, Place from Content Center. Right there is the Place Imported CAD files. I'm going to go back. Right there is the shell model that Dan put together for me. This is version 1 of it. When I go to open it, you'll get a little bit of an hourglass here. It's not a big deal. It just has to read in all those views and families and all the categories. So there's a little bit of reading going on there. Again, I can convert or reference. I want to reference. Under 3D views, he's got a lot of views in this model. Example, 3D view 1, give it a second to come up. So there's a view of his building. Great. But as you notice, it's got 10,390 elements in it. I love the fact that it'll count these things down for you. So I can preview that and say, well, there's the building. And actually right there's the awning that I need to work on. So I could technically use this view. And actually, as Dan mentioned, we did try this once. The first time I said, okay. And it took maybe 3 minutes to open up this assembly and get it on the screen. 3 minutes was not terrible because I'm reading in an entire building, but I told Dan, I said, we need to make this a little quicker since we're doing a live demo. So I thought, okay, well, you know, I'm just working on an awning here. I don't need the curtain wall panels or the columns or, you know, I can start turning off devices. Like if I just turn off the doors, let's just turn off some curtain wall panels, some floors, turn off the roof. I don't need the roof. So as I start turning things off, you can notice I can start reducing those element counts. So you got an enormous amount of control here. In this case, since Dan made it easy for me, I've got an Inventor view, which is basically that building reduced down to that front fascia that I need to work on. Again, I can start reducing there, but I'm down to 274 elements. Big difference from 10 grand. So we'll say okay to this. There's that warning Dan popped up earlier. This view contains 274. We actually recommend less than 250. So what? Break the rules. We'll say okay anyway. and it reads it in. And I don't know why they're complaining about 250. It opens up really quick. And there it is. So there's the front of the building. Again, I can, typical Inventor, put more than one in. I just need the one. So there I've got my Revit model on the screen. So what can I do with it? Well, I can start building with it. The idea of this is I'm building supports for this front porch awning here. So I'm just going to come in here and do a place. And I need to go to my awning support. I've got one built that I think is going to be the right one for this building, but we need to check it. So I'm just going to open that up and set it here on the screen. Zoom in here a little bit. And I want to do a little bit of constraining. So first thing I'm going to do is put this pad on top of this awning. Apply that. I need to make sure it's flush over here on the edge. We'll take that face and line it up with that edge. Apply. That actually looks pretty good. I'm looking at that. Maybe the bowl hole's a little closer to that one piece of pipe. C-channel. But let's work up here on the back. We need this. Need the back side of that to attach to the wall there. So you'll notice that there's no problem taking anything in Inventor and just constraining it to the Revit model. So now I know that that support's not going to be sitting up there too high. That was one of the concerns. If you go up too steep, you end up getting into this no zone there. Again, now that I've got that in there, I can simply place another one. Do a little bit of constraining on that one. Put it over here on the other side. Pop that onto there. Now it looks like it's buried back there, but that's all right. I need to mate that with the back side of that plate. That's the front side of it. Inventor does actually allow you to work through things. So, typical Inventor, you can do that. Since these are Inventor parts, I can pretty much do anything you want. There's no limits to what you can do. Let's just run a pattern of that. Did some pre-checks earlier. I got the measurement. We'll grab that, do a pattern of that one. So there I've got my support structure for that awning. Looks like size-wise, everything's going to work out. My drilled holes are going to be in a good place. It's actually going to be on each side of that miter. Full joint back there. Looks like we're spanning across that. Oh, Dan, it looks like it's going to work.
Yep.
Anyway, with that being said, we can go ahead and save this. And I'll just call this my demo assembly. Now, what happens in the real world is you've got all your work done, you've checked everything out, you've saved it. Get this saved real quick. And we'll close this out. Now, we were going to switch back and forth here, but we knew we'd be tight on time. So what I'm going to do here is I'm going to go to my folder. And Dan changed that shell model. He sent me a second variation of it. So I'm going to basically take the original one and just rename it real quick. I'm going to take model 2 and call it model 1. So Inventor's going to think it's the same Revit model. Well, technically it is the same Revit model. Just to have two of them on my computer, I couldn't give them the same name. So now if I go back to Inventor and I open up that demo assembly, oh, look, the Revit model may have changed. Okay, do I want to update the assembly now? Yeah, let's see what Dan did. Because I still need to make sure that my end of this project is going to work. Oh, I see instantly what he did. He made that awning stick out further. So at this point, what I want to point out here is underneath all these componentries, I still have all my original constraints. I've got all my original requirements. I haven't lost a thing. At this point in time, I can determine if this is good enough, or maybe I need to lengthen this rod and get it to come out further onto that flange. I'm not going to bore you with the typical Inventor editing. That's just what Inventor guys do. So with that being said, let me put this back on the screen and open up the floor for questions. I started answering one question in the chat side a minute ago. If anybody has any other questions, feel free to put them into the question panel and we'll try to answer them live. Anyway, one question that did come in, I'll go ahead and read it off here. For large Inventor assemblies where simplifying the part is still a large file size, can several simplified parts be joined together before making the RFA, like large skidded equipment? If I'm following that question right, I did put an answer in there, and now I can't find my answer. Yeah, basically what I would do is simplify each smaller section, because when you simplify like a sub-assembly, it's going to become a single part, that simplified part. Those can be saved on your hard drive. Now, to put it all together, just make a new assembly. If you've got 5 pieces that were simplified, just reassemble them. Wouldn't take that long for 5 pieces. And then run through the whole BIM authoring on that collective simplified unit. Hopefully that answers. Looks like Dan's answered a couple other questions. Do Inventor and Revit need to be the same release, was asked. The AnyCAD feature is only available in 2021, the latest version, so that kind of answers that. You would have to be on 2021 level. I will point out the Inventor to Revit family, RFA, going from Inventor to Revit, that's been available since like 2010. This year, 2021, they actually have the ability to go from Revit back to Inventor, and that's why we put this presentation together to let people know that. There is one question here. Any idea if an imported IFC geometry in Revit will flow through Inventor? Honestly, we never tested that. We could probably do a quick test and let you know. That'll probably have to be done after the webinar. And David asked about that first question about simplifying the large assembly as pieces. As long as you maintain the links between your simplified part and your assembly, when your assembly updates, the simplified part will update. That will update in the assembly it's used in and go all the way through the chain of command. So yes, it should stay live as long as the links are all in place and files aren't missing. All right. I think that's pretty much the trailing end of the questions. I don't have my clock accessible right now.
I think we're right there. Let's see.
Yeah,
you know,
we nailed that right. 11:59. Right. There's one last trailing question just came in. Can Revit parameters connect to Inventor parameters via AnyCAD? I'm thinking no right at the moment, but I hate to discount that because there's a lot we can do with iLogic and Inventor that we could read in that data. So maybe not directly, but it probably could be done somehow. All right, Ashley, it looks like we're pretty much wrapped up.
Okay, great. Well, thank you guys for the presentation. It was really good. And thank you all for attending. If you do think of questions later, you can just reply to that confirmation or reminder email you received from GoToWebinar, and we can get those to these guys or your sales rep to get the questions answered. Once again, as we close down today, a short survey will pop up, and we would appreciate you filling that out for us. And also a reminder that tomorrow you should receive an email which will contain a link for today's recording. So that's it for that. And thanks for attending, everybody, and have a great day.